Join discord.gg/flat earth and enter a VC check-in room, and someone will come along to VC verify you to get involved with the conversation about our Earth.
Enemy spotted.
Roohif 16.
Now, the anti-flat earthers are on the social media platforms expressing their opinion. They're obsessed with flat earthers. That's all they do is make anti-flat earth videos. Those are the anti-flat earthers.
And there's one important aspect. They have to deny people like deGrasse Tyson. They have to disagree with them.
Yeah, he's wrong.
Yeah, they throw them under
Felix.
the bus. No, every chance they can get.
Yeah, he's wrong about the Felix.
You have to deny.
So he's wrong.
You have to deny globe claims.
And so when Neil deGrasse Tyson says you can't see the curvature from 128,000 feet, what would you say to that, Roohif?
I would show him Bacon's. It's yours, Bacon, right? Yeah. Did you do that one? Yeah, Bacon did one of
Which one?
The left to right curvature.
Oh, yeah. The curve checker. Yeah.
Yes.
Bacon.
Yeah. Bacon's got a website or a web page showing what the left to right curvature should be, and it's should be seen.
But are you saying he has like physical footage of showing left right curvature, or what it should be mathematically?
Yeah, what it should be. That's
Okay,
what I'm
well,
talking about, right?
God damn it, we already know that.
Right?
That's what we argue here all day long.
Right, but Neil deGrasse Tyson is saying you shouldn't see it.
Who the fuck is that?
Tyson's saying you should not see it. He's wrong.
Yeah, but you're saying that Bacon is right because he mathematically can show it, but he doesn't have any physical proof for it?
Oh, we can show you.
Why is Neil deGrasse Tyson wrong? Why is Neil deGrasse Tyson?
He's mathematically wrong. He's made the incorrect prediction.
He didn't even bring up math.
That's what we're talking about.
Actually, here's his math. You can't see the curvature from 2 millimeters above this beach ball. That's his math.
Right. He's wrong. He has made an incorrect prediction for what the globe should be. This is not about whether we do or do not see left to right curvature, right? We're not talking about reality. Since you know more than
Neil deGrasse Tyson, show us not Bacon shit. Tell me your proof. Tell me your shit, Roohif.
My prediction, or showing you left to right curvature in reality?
Left right curvature in reality. God.
In reality, we don't see the curvature, bro.
Nobody does.
We don't, man. Come on, bro.
That's what MDT was saying.
Neil deGrasse Tyson on that. You can't see the curvature.
Understood.
From the ground or from 120,000 feet. You can't fucking see it.
Hey, Roohif, I used to have the same imagination like you, bro. You know, I thought I could see the curvature. I thought there's curvature. There's no curve, bro. There's no fucking curve. Water's flat, my
that's
brother.
your view, right? but regardless of the shape of the Earth, you should accept that there is left to right curvature. Would you like to understand why?
Because math?
No.
Oh, so there is some observations that you can show us left to right curvature, like natural, from Earth. You can see the left to right curvature from an observation on Earth.
Yeah, we can do that, but
who's we? I'm asking you to show it to us.
Yeah, we can do that. I'll show you Rory's.
We can't do anything. I want you to do it. Who the fuck is we?
Me and you. We're having a conversation.
I can't show you the left to right curvature, so it's on you, bitch.
Okay, I can show you that, but I want you to understand that if the horizon is below eye level, regardless of the shape of the Earth, it is necessarily curved left to right. Necessarily.
All right, so you're gonna show me where the horizon looking straight forward is below eye level. Are you talking about the ocean?
Yeah.
Like looking across the ocean? Okay.
Yes. Right.
Are you talking about a superior mirage?
No. We're just the horizon is the same distance all around you, right? If you're on the ocean somewhere, and it is measurably below eye level, right? Therefore, it must be curved, regardless of whether it's flat or
Because
below.
where you're standing, whether you're on a ship or you're standing right there with your toes in the ocean, it's necessarily below your eyesight because even if it's 5 feet, so it's necessarily below your eye level. Is that what you're getting at?
Yeah.
Okay,
You don't see it.
dumbass.
What?
We already know this.
Okay.
You don't
So
see
there's
it.
no issue
It just
then.
looks flat.
Really has nothing to do with curvature of the Earth, though. What the fuck are you
Okay,
talking about?
that's okay. Like I said, irrespective of the shape of the Earth, if it's below eye level, which it is, then it is necessarily curved. So you should accept
don't see
left-right
it.
curvature. Well,
Like you
I'll show
don't
you
see
what it
it.
is.
Well, check. Let me ask you this, Roohif. So, if the Earth was flat,
Mhm.
which to me it is, but but not to me, and everyone else that's in their right mind obviously observes a level stationary plane. That doesn't matter altogether because
One sec.
what you're saying, and what I'm hearing you say, Roohif, is that basically you wouldn't know the difference.
Are you guys actually claiming the atmospheric dome of vision now?
I am confused
No,
on what
he's
you
saying.
guys think that
Here's
is.
what he's saying. Here's what he's saying, and it's just like
I knew
this
this
is
was going to happen.
outrageous. This is outrageous. He's saying that even if you're standing at the shore with your toes in the freaking at the shore of the beach,
Yeah.
and the horizon is actually below when you're looking straight ahead. Horizon is actually below, and it's the curvature of the Earth because but who can know that? Right? It's like
Are
what
you?
curve? Who told you that there was a curvature of the Earth to look at anyway?
Roohif, are you saying that it's the actual curve or just what we see?
I'm saying it's a geometric necessity that if you are looking in the same
So
distance,
are
or
you
if the
saying that it's
horizon,
a geometric horizon or a?
no. Let's
Well,
just
you
say
Then
that.
the
are.
only way you can know it's curved is through math. That's what he's saying. That's what he said the whole time,
Yeah.
ever since we've been talking.
Because
Okay,
you're saying
geometrically,
it's a necessity geometrically that we can only see. I understand what you're saying, but you're always claiming that it's not a geometric horizon. So
we're not talking about refraction.
what? No,
No, we're just
you're
talking
saying that
as
we
a.
can. I know you're saying that we can see a certain distance in each direction, so therefore it looks curved. Yeah, that's what you're saying.
Where I'm saying that if the horizon is below your eye level, and it's the same distance all around you, then geometrically it is necessarily curved. That's just a geometric fact.
It's not though, bro. Where do you get
It's
this
not.
from?
It would look like that to your vision, but it's not
Okay.
geometrically that. Yeah.
There was a good video the other day. I can science that, and basically he got.
It doesn't matter. It doesn't matter. What you're essentially saying is because you're looking down at the horizon, that is Earth curve. So
I'm not saying that.
geometrically, yes, you
But
are.
you're not
Because
No, I'm
looking
not.
down.
well, you
I've
are.
said irrespective of the shape of the Earth. I've said
So
that 3 times.
either you're saying that, or you're saying that it's a an apparent horizon which wouldn't work with Earth curve anyway.
Tim,
So what are you
Timbo,
actually saying?
essentially,
Well, what's he clear? He needs to be clear on what he's actually saying.
Yes,
no,
I'll say
that's
it
what I'm
again.
saying. Essentially, nobody looks down at the horizon. You just look as far as you can see.
Straight out.
Okay. The horizon is measurably below eye level. Measurably.
Where's the
Okay.
horizon? Is it at 1.22 miles?
No, because that ignores refraction.
Okay, so where is it then?
It depends on the gradient, but it's around on a typical gradient about 1.32 times the square root. Blah blah blah.
So you're seeing the curvature of an apparent horizon?
We're talking, as I said again, irrespective of the shape of the Earth, right? Irrespective of the shape of the Earth. If the horizon
Yeah,
is the
but it's
same
not a
distance around you,
geometric. It's not a geometric claim, it's a visual claim.
Wait, when you say geometric, do you mean without refraction now? I'm just talking geometry.
No, I'm just talking, I understand if you look in one direction and you can see 10 miles and you look in another direction, you can see 10 miles all across that arc of your vision. You can only see 10 miles. So therefore you're saying it looks curved. Yeah? Is that what you're saying?
No, I'm saying if the horizon is below eye level, which it is,
But you're at sea
and it's
level.
the same distance, eh? Well, get slightly higher than sea level, right? And then the horizon's going to be below.
Well,
Right? If it's
yeah,
the same
technically,
distance all
yeah.
around, yeah, if it's the same distance to the horizon all the way around, and it's below your eye level, it is necessarily curved. That's a geometric fact.
It's not a geometric fact, it's a visual thing.
Yeah. How else can I? We keep using the word geometric, and I
It's
think
not
you
a
mean
physical
unrefracted.
thing, though, is it? It's not a
No, what
physical
he's trying to
thing.
say is this, right? You can't see the curve, but it's there, pretty much.
No, I'm saying it is there, and you guys should accept that it's there because the horizon is
No.
below eye
Exactly.
level.
That's why I'm saying
The
like you can't see it, but
refracted,
it's there.
the refracted horizon.
It is refracted, but we're not talking specifically about refraction right now. We're just talking simple geometry.
If you're
Bro, what are
talking
you
about the
talking about,
horizon,
man?
if you're talking about the horizon, you're talking about the refracted horizon.
Yes, right, but we're not specifically discussing refraction. We're just saying that it's below eye level, therefore it's curved. Whether it's refracted or not doesn't change that. If it's below eye level, it is necessarily curved.
Okay, but there is a problem because if you go to a beach and you are looking far away to the ocean, you may think there's a curve right there on front, but if you look 180 degrees, to left and right, where is that curvature?
If you are at the
Is
beach,
the Papal Tower roller shaped?
right?
You see the
If you
problem because it's according to that spherical trigonometry, it should curve every direction, but
yes,
it doesn't. You see, you just are looking forwards. Try look at sideways because the distance sideways it should be bigger, but I don't see any curvature. So bye bye.
okay. What I'll do is I'll just put it's a 5-minute video, and it uses a 6-minute video. It is the same analogy I've been using for a couple of years about a hula hoop. All right, please watch the video, please.
Hey, Roohif, the horizon's
Yes.
refracted, bro.
Yes, it is.
So for you to claim that it's anything concrete and therefore proof of something is an obvious fallacy, bro.
All right.
You know what it is? It's a reification Roohif fallacy.
Okay. For the 5th time, irrespective of the shape of the Earth, if the horizon is the same distance around you and it's below eye level, which it is necessarily curved. Please watch
How
the
can you
video.
see
I'm
past
going on
for
mute.
why it is?
Say again.
When it
Timbo,
comes to
what?
seeing things on Earth, it's a bit more difficult to see stuff when the sun is not upon it.
When Timbo says the atmospheric dome of vision, do you mean like altitude azimuth coordinates? No. Okay. That's what I thought you guys meant by that. And yeah, we've used an Altaz. I've got an Altaz mount. Yeah.
Dude, in your own worldview, it's a refracted horizon.
Correct.
So for you to use it as if it is an actual thing and not an apparent thing, like it's an apparition according to you guys.
It is a
I
physical
see a problem.
location.
I see a problem in that video because he's putting the hula hoop above the horizon, so
No. At
it's
the
just a
horizon.
fallacy. No, it's I'm gonna take a print screen.
Yeah. But when it's below, right? When it's below his eye level, it's curved, right?
He's putting above. the horizon.
Oh yeah, sorry. At the end, yeah, the end he raises it above
That's a
his head and it
fallacy.
curves up. Oh yeah, sure, whatever. Like he's putting it above his head, fine. But it's below, right? When it's below his eye level, it's curved, necessarily
Oh,
curved.
but it's flat above the horizon. That's a fallacy, you know.
What? No, it's flat at eye level. It's straight. It's a straight line at eye level.
At 3 minutes and 34 sorry, 3 minutes and 34 seconds. Watch that.
3:35.
I'm gonna save it. A second.
3:35.
3 minutes 34.
34. Yeah. So he's looking at eye level.
No, he's putting his hula hoop above the horizon, just
Of the horizon.
to appear flat.
We don't know whether that's a horizon or not, like whether he's
Yeah.
clipped a
The
plane.
green, the line, you know, you see that line, the green, and
Yeah,
then you see
if
blue,
that's a
and then you see the hula hoop that he did put above the horizon. So
yeah,
that's
so that would be curving up, right?
no, he's just fooling himself.
If it's above the horizon, then it would curve up.
Just a second.
Left to right curvature.
You
Curve
cannot
up.
put above the horizon.
Yeah, I agree in reality, right? But his
So
point is that if
he's
it's
just
below,
fooling himself and others. Just let me
Well-
get the print screen.
right? So it's above, so it's curving upwards.
You
When it's
cannot put
below,
above
it's curving downwards.
because it's not according to reality.
Fine, he's
just
doing a
fooling himself.
simulation. Fine.
He's putting his hula hoop above the horizon, so that's bullshit.
Okay, and it's curving up,
Okay,
right?
he's not
Curving up.
doing that correctly. So let me see.
Yeah, and it's curving upwards.
He's just putting the hula hoop above to appear to be flat, but you see the horizon is still is below. So
Right. So the
he's
the hula
fooling
hoop's
himself.
curving up, right?
It's just a point of view, nothing more, you know. And this is
Okay.
not according to reality. This is just a simulation.
Yes, but the hula hoop is
You cannot,
above the
if
horizon, right?
to appears flat, he has to put above the horizon. So that's bullshit right there.
It's
You
above the
see,
horizon.
it's
you can see it
no,
curving
no.
up, right?
The limit of the horizon is that line where the green finish
Green and blue.
right
Yes.
there. Okay.
Yes.
So he's
And the hula
putting
hoop is above that.
He's putting his hula hoop just to appear flat above the horizon.
It's not flat. It's curving upwards, right?
Man, he's putting the hula hoop above the horizon to
Yes.
appear flat, a flat line.
It's not flat. It's curving up. Can you see it curving up? Are you listening?
No, he's doing this, you know, with a hula hoop, putting above the horizon to appear just flat.
Yes. For the sixth time, I agree in your screenshot. It is above the horizon.
But I don't care.
Which way is it curving?
I don't care
So
about
when do you see the horizon curving up?
You
Roohif?
don't. Well, you don't.
What are
The
you
point is that if
talking
it's
about
below, because Miguel, is it Miguel? Yeah, I assume it's Miguel. Thinks that he's doing some. I don't know what Miguel thinks. I agree. I violently agree, Miguel. If it's above the horizon, it will curve up. The hula hoop is curving up because
When
it's
is
above
it
the
ever
horizon.
going to be? When is it ever going to curve up?
Yeah, it's not. It's not. Right? He's just showing the hula hoop above eye level, and it's curving up. Put it below eye level, it'll curve down.
There's a problem. He's saying that the horizon is a circle.
Do we disagree with that?
Man, I just said to you, you are just looking forward. But when you are looking at one beach, you see the ocean, you can see more at left and right than you are looking to forward. So the distance is bigger at the right and left. So it curves. If it curves where you see that horizon forward, so it should curve sideways, but it doesn't. So
Hang on,
the
did you
earth is
say?
not holy paper. You know, I did post above a meme. The earth is not a paper towel rolled shaped.
Right, but did you say the the
I
horizon
think
distance is different in different
when he
directions.
see when he is in this video, he's saying the horizon is a circle. Man, he's not
Yeah.
talking about reality.
Do you
Because in reality,
disagree?
in the reality, I don't see any circle. I see when I go to the beach, I see a flat horizon, perfect
Yeah,
level
from the
there.
beach. Right, from
And
the beach, it's
if
going
you
to look
think
incredibly straight.
if you think when you are looking for at your limit
So
vision,
when's it
you
going to
think,
look curved?
yeah,
Yeah,
it
you need
doesn't.
field of.
I,
Well, hang on,
I
wait till we
don't see
go.
it. I don't see it. You may think when you are looking for with your limit vision that the curvature starts there, but in the limit of the horizon, but it should curve sideways. But I don't see that, so it doesn't match with reality. So
Okay. From the beach, right? The way to see horizon curve is first of all to get elevation and a fairly wide field of view. Right? They're the two factors in left to right curvature. From the beach at 6 feet, indistinguishable from straight flat horizon. Indistinguishable. Did
let me
I
get.
hear you say that the horizon is different distances away, depending on the
No.
direction?
No, I'm saying when you are looking from a beach, when you are looking, you see the ocean 180 degrees, just like
360, yep.
yeah. So so if the curve starts when you are looking forward at your limit vision, why it doesn't curve sideways? That doesn't match with the spherical trigonometry.
From the beach, right? From the beach, you are going to see, what do we call it? Front to back curvature.
All right,
Right? That's
Roohif. You
Oh,
mean from
man.
every beach every time?
sorry. If you're at
Listen,
the beach at 6 feet, it's going to be flat. You're going to be indistinguishable from a straight horizontal horizon. You're
in
at the beach.
every situation, whether you're on a lake or an ocean, everything, what you're saying is completely true every time when you're standing at the shore of a beach, 6 foot observation height. The horizon is, you're saying it's under your eye level, but it appears to be at eye level, but it's really under eye level. And but you apply the math, and then you know that it's not, that it is curved once you apply the math.
No, at the beach, if you're at 6 foot, the horizon will be indistinguishable from flat.
It's
Flat straight line.
Well, no shit, bro.
Right? Get above the surface, get above the water.
Okay, so
Like I
let's
said,
go 128,000 feet and see
yes.
what happens then.
Yep.
Yeah. Let's do that.
It looks flat.
Yeah, it looks
No.
flat from there too.
What about Mage 2 or Mage 3? Mr. Sensible.
Mr. Sensible.
All right,
That guy
How
Dwayne
about
Kellum,
Roohif?
Flat Earther.
He doesn't even
How
know if
about
he's
Roohif?
living in reality.
How about Dwayne Kellum, Flat Earther then?
And Kellum, yes,
Dwayne,
yeah, he has some
right.
excellent videos. Yeah, and it shows the flat Earth from a high altitude balloon. Yes.
How about I go back and get Dwayne
Roohif,
Kellum?
can you agree? Can you agree that if you get to altitude, that when you start it directly in front, you'll see, and then as you start looking left to right, that your vision will be impaired due to atmosphere? Would you say that?
Not really following. How about I go and get Dwayne Kellum
Why?
and
Why
show
not?
his.
So you
Dwayne doesn't
see,
come on live shows, but
it's straight out.
he's put his videos out there.
If you
Anybody
get
can watch them.
if you get to altitude and then you can see 20 miles in front of you, yeah,
Yeah.
you can see 20 miles, but because of atmosphere, yeah, we're just going to use atmosphere because it's an easy word to use. So your circular vision is 20 miles, yeah, because of atmosphere. So therefore, to you, it may look curved because you can only see 20 miles in each direction, but it's only a visual thing. Can you admit that?
Only a visual thing.
Can you
I've got to
admit
think about.
if you see 20 miles in each direction in a circle because of atmospheric conditions, that it would look like it's curving, but only due to atmosphere. Because you can only see, because you're looking down. If you're going to elevation, you're looking down. Yeah.
Yeah, and
So if
that's
you're
the
looking
point.
straight ahead, yeah, but it's only due to vision. It's not due to the curvature of the Earth. It just looks like that
Okay,
in
then.
some instances.
Okay, I think we almost agree that if the horizon's below you, then it must be curved because you're seeing
No.
the same distance. No?
You said from elevation.
Yeah.
Yeah. But if you're at elevation on a clear day, it looks flat.
I would disagree. I'm going to go and get Dwayne Kellum's footage. I'll be back in a minute.
Can you show us on a clear day a picture of left to right curvature?
By the way, I already posted Dwayne Kellum's channel, YouTube channel. So there it is right there. Anybody wants to watch his videos, they're right there. I just posted it.
All right,
Like
back in a minute.
what you're essentially saying is when we can only see a distance, a shorter distance to the horizon, that it looks like a circle. It looks like it's curving. Yeah, that's what you're saying.
I'm saying, again, irrespective of the shape of the Earth, if it's below eye level and you're seeing the same distance around you, it must be curved.
It's got to do with atmospheric conditions. It's got nothing to do with being below eye level. It would have to be a combination of the two.
I would encourage you to watch the hula hoop video from I Can Science That. Anyway, I will be back in 5 minutes.
I can imagine the hula hoop. I know what you're saying.
Okay, cool.
I
Anyway,
get it. I understand it. But it's a hula hoop. It's not reality. Does anyone disagree with me?
Well, I certainly don't, but
yeah.
Well, we necessarily
when you talk about the whole, go ahead. I'm sorry,
necessarily
Kim.
see in a circle because that's just the way our optics work.
Yeah. So
But
we're
if
seeing.
anything's curving, it's the circle of our vision, not the Earth.
Yeah, exactly. Yeah, and I think that's what he's kind of like. That's what he's talking about because he can't be talking
Hijack
about the
the circle
physical.
of vision.
Yeah, he
He's
can't be talking about a
misdescribing
physical
the.
thing, can he?
Yeah. That's like every time Roohif comes in here, he makes some other bullshit up.
They've all been coming in together lately. Bacon, that other dude. Who was that other dude who's a celestial navigator?
It's
He
because
came
they're
in with
anti
bacon.
flat earthers and they have to keep doing this just to see what we'll say so they can just, I don't know.
I just want
He's
to say
essentially.
It's like a freaking.
Yeah. Sorry, go, Larry.
Go
No,
ahead,
you're good.
sorry.
No, real fast. I just want to say these people believe what I'm about to say is true. So I posted this 29 minutes after hour. Gravitational waves that LIGO detected distort the geometry of space-time by 1,000th of the width of the nucleus of an atom. These people believe that, right? So you got to realize who you're talking to.
So they have to distort pictures as evidence of curvature? Oh, so you manipulate the picture to show that this
I'm
is
just saying
not
they're
admissible.
gullible.
Yeah,
a court of
hey,
law.
Larry, they think they're dumbing it down for us, right? So that they can help us understand why we think the Earth is flat.
They're gullible. They'll believe anything as long as the government says it. Watch, now that the U.S. government's been talking about aliens, guess what they're all going to start pushing?
Well, it's already starting to happen, but yeah.
In that picture that Roohif just posted, look at the top. You see the clock? It's not round. It's not a circle. So it's like, I mean, you see the distortion that is occurring in that image. I mean, look at the clock above. I'll take a print screen too. So the clock is not a circle.
Because I've compressed it, right?
Compressor, right? Okay, so
yes.
Let's see.
Did you compress the lens? The lens image?
Shrank the width of the thing to make the curve more obvious.
So on a lens, do you get curvature on the outside of a picture?
You can, and that's why Mage is a better one, because they put a straight line across the...
So
across the
what you're
camera.
saying is this could be lens curvature.
Oh, it could. It could.
Yep.
That's why I said Mage is
Okay.
better. So I'll get Mage.
Well, I mean,
There you
do
go.
they make any cameras that have a
No, all
completely
lenses are
flat
curved.
lens? Yeah. I mean, there's no such
Yeah.
thing as a completely
Look,
flat lens, and there's a
just look,
reason for that. And if you don't know why, then Roohif, man, you better check.
just look at that clock. I mean, you just by looking at that just foolish.
It's like your freaking eyeball, not flat. You know what I'm saying? That's why they don't make cameras lenses freaking flat.
Right.
Anyway.
But what do straight lines look like in a photo then?
Let's fake reality. Let's do
Well, if you
instead of
compress them, they'll be curved.
exactly.
Sorry, you think a straight
Yeah.
line compressed makes a curve?
Yeah.
Really? Do you want to demonstrate that?
In
You
a
didn't
camera,
just
it
say that.
does.
No, you didn't just fucking say that.
No,
You're
a straight line in a
fucking-
photo. If I take a photo and the line, and I look at the photo and it's straight, are you saying if I compress the photo, it becomes a curve?
Luna.
It is compressed. Just look at the top. Is that a circle at that clock? I mean, it's that real.
It's compressed.
It's
The
compressed.
question is,
Thanks.
does
So
it
it's
make a curve? And there's
if
no
it is
curve there.
compressed, the whole thing it's compressed, so you can make a curve right there, like
The
right
question,
just like
Miguel,
that.
the question is, if it's straight in the photo, does compressing it make it curved?
Man, you can
You
fool
go, Ether
yourself.
Chris.
Okay. If
And
if
you guys
the camera if the camera is held directly level, then it won't curve on certain lenses.
Yep.
But if it's slightly out of level on all lenses, the straight line, if you compress it, will curve.
When you say a straight line, do you mean a straight line in the photo or taking a photo of a
In the
straight
photo.
thing?
In the photo. Yep.
Wow. So if
Yep.
it's
If
if
it's
you're
not
saying
dead level, if the camera's not dead level, then it has that has a curving effect to all lenses have that. Whether you see it, but
oh, hang on.
it might be slight, but if the camera is dead level, then you won't see it.
Okay, but just to be straight, just to be clear. Oh shit! Whoops.
Just to be level. Just to be level.
my daughter's asking for shit.
I'm
So,
gonna level with you right now.
so if I have a photo and there's something straight in it, so I can draw a straight line across the photo and it matches, like it's straight in the photo. Are you saying if I compress that photo, that straight line becomes a curve?
Depends on the photo.
Well, let's assume it's straight in the photo.
Well, how straight in the photo?
Perfectly straight. If it's
Well,
perfectly straight in the photo.
if it's perfectly straight, it's not going to be curved, is it?
Okay, good. So compressing it doesn't make a curve; it just accentuates a curve if it's
Depends
there.
on the lens. Yeah,
Sure.
but you're talking about in a photo, yeah.
Yeah. So in the photo itself, let's say you take a photo of a straight thing.
It could be dead level in real life.
Yep.
Then when you take a photo of it, because of lensing, and then you compress it, it can be curved. Is that correct?
Yes, because but it's not the compressing that makes the curve.
No,
right? It's the lens.
already there.
Yes. Okay. Cool.
In the photo, yeah.
Okay. Good. Good.
I did post a video by Dr. John D. And
Yep.
he did took pictures here in Portugal, and when you have time, go look at. You can do it, by yourself. You can go to a beach, take a picture, then move away, left or right, go to another beach, take a picture, and so on, and then show us the curvature.
With a left to right curve.
You can go watch the video and.
Yeah, if you're at the beach, you're not going to see left to right curve. You're too low.
Welcome to Flat Earth.
Okay. Okay.
Well,
If
the
you are at
horizon's
the
below
beach,
eye level, right?
right? But the left to right
And you're
curvature is a
saying that anything
function.
above or below eye level is going to curve visually, right?
Yep. It curves. Yep, it
Okay.
curves.
Visually.
Are you saying not physically? I'm not going to agree to not physically. It curves.
No, you're saying that in your vision, anything above or below eye level is going to have a curve to it, right?
All right. But do you mean visually as in not physically?
Yes, visually.
Then I disagree with that. It will curve physically,
Well, is
and you will
that
see
not
it.
what you said? Because you said that anything above eye level is going to appear to curve upward. You
Yes.
said the opposite as well. That's not
Yeah,
a
'cause
visual
you
effect
said
you're talking about?
you said on the flat or a curved Earth, so then you
Yeah.
would agree that it is visual.
Yeah, Roohif, is that not a
And
visual
physical.
effect you're talking about?
And physical. You're seeing it, so it's visual, and it is physical.
We're seeing a physical curve, or it's an optical effect.
Again, this idea that physical and optical are mutually exclusive, I completely disagree with.
Dude, are we looking at a physical curve of an object
Yes.
or an optical effect?
We are seeing physical curve with our eyes. Yes.
Okay, a curved object.
Yeah, it curves.
So what's this business of something being exactly at eye level being a straight line, right?
Yeah.
But if it's above or below that eye level, it's going to have a curve one way or the other.
Yep.
Yeah, we're an hour later into this, and he hasn't really explained it. Except for he said it. He said it. No, you did. You posted a video, but go ahead. Go ahead.
Yeah, what I'm trying to get
Fucking
to is he
ridiculous.
said even on a flat Earth, right, where the surface of the Earth is flat, if the horizon is below your eye level, which it is, it would necessarily have a visual curve to it. Now you're saying that that would actually be a physical curve of the object being the Earth. So
Oh,
what
he
was the
never
point in
said it
doing
was
all?
physical. He never did,
Well,
heretic.
he's switching that to now. Now he's switching it to that.
Okay, go ahead.
Yeah, now he is. Yeah.
Okay,
Yeah, but
never mind.
he said if it's below your eye level, then it must have an optical curve to it. Isn't that what you said, Roohif?
It must be curved, yes.
And you said
Optically.
it must.
Yeah.
Yeah.
Again, you keep
Optically
using
or
the word
physically?
optically.
Come on, man.
Yeah, physically curves, and you see it with your optics.
That's fucking
Okay, so it's a
These
flat
words are
Earth.
not
It's not.
mutually
It's
exclusive.
not. Okay, listen. You said even if it's a flat Earth, it's going to have a curve to it if it's below your eye level. So that's a physical curve of a flat Earth, according to you.
Well, you guys, if you guys could have an explanation for why the horizon is below eye level.
Wait, now you're putting the burden on proof on us after you talked all that shit. Now you're gonna put the burden of proof on us when you came in here talking that shit. Why don't you show us what you're talking about? You say, and you're gonna say, "I already did." I already know what you're gonna say, dumbass.
I'm going to say that you guys don't have an explanation for why the horizon is below eye level.
Explanations are as good as bullshit.
The reason why the horizon would be at below eye level is because you're always above the ground.
Right, but it should approach eye level because it's effectively like the flat plane extends.
You're looking far away because you're looking far away. You can't see when you're looking at your toes and then you look far away. Of course, you can't see the water that you're standing next to, even though it's level and stationary. It's going to ramp up, apparently ramp up to your eye level. It's not.
That's the point
that
you're
it's
making.
lower. Yeah, but you're saying that it actually is lower, which it essentially is true.
Well, he's saying that
at the distance,
he's saying it must be
at the
lower because
distance.
Well, if he's saying that it must be lower due to Earth curve, then the horizon must be geometric. Does it appear geometric?
Because it wouldn't be if we were standing on top of a ball. It would always be lower, but it's not. So anyway,
hang on one second.
This is the dumbest shit I've ever heard. I've heard a lot of dumb shit from you, Roohif, but this is the dumbest I've ever heard from you.
He's saying, he goes, you guys explain why the horizon is always below eye level. It's because it's
Don't have
lower
to.
than you at all times.
And we don't have to anyway. It's a burden reversal. He's got the claim about why it's below your eye level. He's the one who's got to validate that. It's not on us to come with a counterclaim and for his claim to just be true by default.
So Helio said that it rises to eye level.
No,
Right.
I did not
No,
say.
it looks like it.
It looks like it does, but dude, do you guys agree with me? This is the dumbest shit that Roohif ever
Yeah.
came up with.
It's
your
pretty
worst
dumb, but my
argument
lady's
so
bitching at me.
far.
I gotta go. Sorry, guys.
No, you're right, man.
Hey, go ahead. I'll
Peace,
shut
bro.
up. Go ahead.
Yeah.
Okay. If I'm 100 meters above the water,
Yeah.
right, the horizon gets nowhere near eye level.
Depends how far out you look. It would start to decrease in angle.
It's
Yeah.
about a third of a degree. That's huge.
Not really.
It's
If you're
huge.
just-
How huge is it?
Yeah, if you're just
Third of a
looking
degree.
at it, if you're just standing there with your mate looking off the top of a mountain, it looks like the horizon is at eye level. It's probably not because it's below you. But, but you're saying it's a third of a degree. No one's going to be able to pick that up unless you
I can.
measure it.
Yes.
Like with your
Yes.
eyes.
No, not with your eyes. Your eyes,
Of course
good
it's- well-
angle measuring devices?
So you're saying that because the horizon is below your eye level, that the Earth is a globe?
The measurements to the horizon match the globe model incredibly well, and there's no explanation from flat Earth.
When do they do that?
Hundreds of measurements to the horizon.
Okay, so it's physical. The horizon's physical.
Yes.
So why is it further some days than others?
Yeah, it depends on the atmospheric conditions. But if you're
So it's
above the
not
surface
physical.
by a decent amount, I didn't say it's not physical. How does that mean? If light
So
takes-
is it the magical mirage of refraction that makes it appear somewhere that it's not actually where it could be according to the globe math?
Yeah,
This is
if you
what you're
say-
saying.
say
Come on,
these-
bro.
Say these observations match the globe perfectly, but every day is
often.
different, so it doesn't. It's fucking weird, man. What
Okay,
you're
two
saying
things.
is really weird.
Two things. One, get above the surface where refraction is predictable, and then the measurements will match very, very
Then
closely.
you're looking
to
at
the
a
globe.
horizon of elevation. So
Yeah,
your horizon
Timmy,
could be
excuse
a
me.
different height.
So, Roohif, what height would you have to be to actually see the physical curvature of the Earth?
Second point.
Oh,
if light,
you're gonna have to give me that goddamn number right now.
get above 100 meters above the surface, and the refraction is very predictable.
All right.
Around
so
what?
then, from 100 meters above Earth, you can see the physical curve, but you can't see it from the ground, and you can't
Always
see it from
physical curve.
128,000 feet. So you
How
have
is
to
it
be
always-
100 meters above the surface of Earth, and who observes it from there?
Okay. Now, you keep using this word physical, right? If light bounces,
See what he's doing, Timbo.
Ilya, I'm trying to get to my second point that I started 5 minutes ago.
All right,
Okay.
go ahead.
Physical, right? If light bounces off a building, whatever it happens to be, and takes a curved path to my eye, is the building physical or optical?
Who cares?
It's physical, right?
Well, you can see it,
Okay, but it's a physical building.
and you know where it is because you can measure to
Yeah.
it.
Okay, but light took a curved path to my eye.
How do you know that? So you can.
Because-
So can you measure the distance to the horizon?
Oh, generally no, because it's hard. You need markers. You can measure the
So
angle.
you can, you can measure a distance to the building, but you can't measure a distance to the horizon. It's
No,
not
I
a
can't.
good analogy.
What is the reflection of the light you
Curved
see from the
path.
building? Curved path to my eye. Where the fuck did you come up with that
So
bullshit?
you're saying
Roohif?
that you can basically visually see something that'll look curved to you, but in reality,
No.
it's actually flat?
The point is that it's a physical object, just like the horizon is. But the fact that light takes a curved path to my eye does not make
No,
that
wait,
object
the
or the
fact,
horizon
the fact.
non-physical.
Now if you said it's a fact, that means it's a fact. Tell us how this light reflecting from a building that you saw from a 50-meter freaking observation, or the fact that it's curving back towards your eye, where are you getting that shit from, Roohif? This
We
is the
have a
most
density gradient.
ridiculous fucking nonsense that I've ever heard you say, and you said some pretty fucking weird shit. This is
Pretty
nonsense.
silly, man.
Okay, we have a density gradient. It bends light.
Yeah, you're looking vertically. I
Who
mean,
is
you're looking
we?
horizontally.
Now we're back to who
Looking
is fucking
horizontally,
we.
so
Right, that's
All right,
correct.
I'll shut up, guys. I'll shut up and
no,
I'm
you're
gonna
all right.
smoke.
That's
I'm
correct. We're
good.
looking
Yeah,
horizontally.
I'm getting frustrated
Yes,
with Roohif
I
right
know
now
what you're
because
saying. You're saying
he's making
because it's
shit up.
lower, because it's a higher density down the bottom. It's grabbing the bottom of that light and pulling
Yes.
it down. Yeah.
Yeah.
Okay. Have you got a scientific demonstration of that doing that through air?
Yeah, it does it through nitrogen particles. Yeah, there's
Yeah,
Maxwell's
nitrogen. So
equations.
you've gone. So what's the refractive properties of nitrogen?
Nitrogen
Is
and
it the
oxygen
same as
make up like
same as
99% of our area.
same as air?
What temperature was the nitrogen when you did this test?
Oh, I didn't do the test. They do it in the lab.
So in a lab.
What are you
Yeah.
talking about then? What was the
They
temperature of
test
the
the
nitrogen?
refraction. They test the refractive properties of air at various temperatures, various pressures in a lab to get the refractive index.
Was it liquid nitrogen?
No.
What was gaseous nitrogen? Room
Yes,
temperature?
air at various temperatures.
What were the variables of these temperatures?
Yeah, well, temperature's a variable, pressure, humidity,
Right. But
wavelength.
what were the temperatures of the air?
Oh, I think they did. I'll have to look it up. I don't know, between minus something and, I don't know, 40 degrees.
This is what you do, Roohif. You just make stuff up, and then you come in
I'm not
here,
making stuff up.
and then you expect to catch someone out because they, because you're saying all these sound like clever things, and
Would you like the paper, Timbo? Would you like the paper that brought together
I don't know.
all these refractive index studies so that we have formulas for the refractive index of air at pretty much any temperature?
Okay, how much does it? All right. Well, how much does it bend? Go.
Yeah, the typical gradient is a change in refractive index over per kilometre of negative 0.000022. That's the typical
But
gradient.
your claim was that all these observations fit the globe perfectly.
Very
But
closely.
none of them actually do.
If you're above the surface, yes, they do.
You have to use a sliding scale of refraction.
No, I don't.
That can actually take it so it can actually bend around your ball and hit you in the ass.
No,
That's
once
what
I'm
you
above
have
the
to do.
surface. No, I don't. Once I'm above the surface, you can hold me pretty close to standard refraction.
What about sea level?
No, because it's highly variable close to the surface.
So the horizon that you're claiming is curvature. Is it physical or
Yes.
optical?
Those words are not mutually exclusive.
They are.
No, they're not. Do you know optics? Optics is a branch of physics.
Does your physical horizon move?
Yes.
Okay, how does it move if it's a geometric number?
When you say geometric, do you mean
It's a physical
unrefracted?
fucking thing. You know exactly what I mean. You have a physical fucking ball where the measurements to the horizon should be exactly the same on all parts of the ball over water. Now, how the fuck can the horizon change distance if it is physical?
Right. If we had no atmosphere, then yes, it would be 1.22. But we are looking through an atmosphere, and that typically curves it downwards so we can see a little bit further around the ball. Right. So that point, that kind of
How
tangent point, depends on the gradient. But yeah, like I said, typically 1.32 times blah blah blah. That's standard refraction.
So why can we see the horizon past 10 miles?
Yeah, strong gradient, like the black swan.
So you say typically 1.3 miles, but in order for you to see 10 miles, you'd have to times that by 9.
Yeah, those conditions, that gradient that's required, those conditions do exist.
Actually, no. Sorry, I did the maths wrong then. You'd have to times it by what the standard refraction actually takes it out by. So it was only 0.1 of a mile. Yeah. Extend your vision 0.1 of a mile. So at 1 foot above 1 foot above sea level, you go from 1.22 to 1.3. So it's 0.8 of a mile.
Well, hang on one second.
That's standard. So it's only 0.8 of a mile. So if you're seeing 10 miles, it's rounded up to 0.10. It's almost what's that? That's 100 times further than what you should actually see.
Yeah, I'll be back in 30 seconds.
Huh.
Yeah, I'm so glad that Roohif is here because I would probably be talking about electron proton production in the vacuum with the Schwinger effect, and I know you guys don't like to hear about that.
It's all interesting.
Electron production in a vacuum. Something out of nothing.
Someone else can jump in. I've got to mute up.
Particle production in a vacuum.
All right, I have returned.
So glad. Please continue.
Yes. In terms of pushing the horizon further and further away, it's better to look at it in terms of how strong the gradient is compared to standard. So I gave you that number of blah, 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 22. If the gradient is 157, which is about 7 times stronger, then your horizon, you basically don't have a horizon, right? The horizon is infinitely far away because the light is bending at the same rate as the curvature of the Earth. And those conditions, 7 times stronger, do exist measurably. I can show you the measurements.
Okay, if the black swan is not enough to you, because you can see like 10 miles away, how about like 70 miles?
70 miles? What do you mean?
Yeah.
Between where and where?
I'm gonna post. Let me get adapted.
Yeah, if you're close to the surface,
With low
I don't care.
humidity in the air.
Where are we at? Where am I looking?
I'm gonna post. So this is second. This was my this was my 2011. For all the data. Point A, Lake Titicaca in Peru. Point B, Cordillera Blanca, border with Peru and Bolivia.
Yep.
Telescope high there. Achieved distance 110 kilometers, almost 69 miles. With low humidity of the air. Where is that curvature? So if the black swan is not enough, the black swan 10 miles. It's not enough to you. But how about 7 times that?
Yeah, I would be very surprised.
Yeah, you are very surprised. I want you to go to that lake and prove to us that's a curvature there.
Right, and
because
I would say
someone did try to debunk this, and they give up. They just give up because they found no curvature. So
okay, is there a video?
I don't have here. I just have here. I'm at work right now. I don't have.
Okay, but does a video exist?
But I have this because I have been posting this. So this is like almost 70 miles away, and in that lake you don't see any cover with low humidity in the air. So
humidity is not a big factor.
I know. You are contradicting yourself. You just said the gradient of the air, but you talking about refraction, and you now telling to us that is not a big factor?
Humidity is not a big.
You are just
Humidity is not a
bullshit.
big factor.
Oh, if you have high humidity in the air, it accounts to to visibility. But
Yeah,
now
visibility,
you talk,
yes. Yeah.
yes. So you talk about refraction, blah 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 blah, and now you are saying it's not important. So you are bullshit.
Humidity is
If you
not a big
if
factor in refraction.
oh so
Would you like a demonstration?
no, I want
No.
a
Okay.
citation.
Okay, I'll give you the formula that was
No,
empirically
I don't want the
derived.
formula. I want the citation that
Okay, Sidor
what you just said.
1996,
That
refractive index
no,
of air at
I want to
blue to
say
near
a
infrared.
citation where you say humidity in the air doesn't,
It's not a big factor.
Yeah.
Yep. Sidor 1996, there we go.
I don't
If you
want
don't want the
formulas.
formula, then you have to
No,
do it
I
yourself.
don't want the formulas. I want a citation that to your claim. Humidity in the air doesn't, doesn't change the visibility.
I didn't say that. I said
You just
humidity
said
does
right now.
No, I didn't. Humidity does affect visibility, yes.
Yes.
It is not a big factor in refraction.
Oh my. You are just
Listen to my words.
You have. I don't want equations. I want a citation for what you said.
The citation is the formula. I've given you the citation to the paper. All right, you can see for yourself how much effect humidity has. It's not a lot.
Anyway, that's bullshit. So,
Okay.
Black Swan, 10 miles away, no
Okay.
curvature. 7 times that, no curvature. Where is that curvature? In your fairy tales dreams or what?
Yeah, I'll happily analyze your
don't
photos now.
give me bullshit equations. Show me reality.
You
Go to
don't
that
want
lake
equations that were
and prove
derived
to us
empirically?
there's a curvature. Okay, but
Okay.
you don't even account the humidity in the air. So
I'm telling you,
just
these formulas
contradicting
account for
yourself.
humidity.
I don't care about formulas. I care about reality.
Yes, these formulas were
70
empirically
miles away,
derived.
70 miles away, no curvature. Where is that
Right.
curvature?
Okay, these formulas were
I don't
empirically
care about
derived.
formulas. No
Okay.
math. No math.
Okay.
I care about
Let's
reality.
not.
You don't have nothing. You until now you have nothing. You just that's just anti flat earth guy. You go to your YouTube channel and you are doing videos against the Intu and Quantum Eraser and so on. So you are just anti flat earth and you care about just formulas, but not according to reality. So
Okay, I'll say it again.
Continue your bullshit.
Okay, these formulas were empirically derived. Do you understand what that means?
I don't care. I just said to you,
You don't care. Okay. All right,
don't give
I'm
me
out.
formulas. I
I'm
care
out.
about
See you later.
reality. If you're gonna wait, you see it. They just care about math, but reality, they don't care about reality. Just bullshit.
Since he's gone, can I talk about this now?
Yeah, go on.
So I posted the link and the download and all kinds of sources cited and all that stuff. It says one might then compare two different selections and find out that one particular vacuum is excited with respect to another choice of vacuum. Particles have been produced. So, of course, I'm talking about the Schwinger effect, how they create particles out of a vacuum. Obviously, if you don't believe in the ether, this is the first law of thermodynamics violation. So I don't know that they're doing this, but if they are, then it looks like they're creating particles out of something, because it doesn't make any sense that they could create particles out of nothing. Because what is nothing? That's a concept, right? Nothing doesn't exist. So when you look at the Schwinger effect and you're doing research on this, they're creating particles out of nothing. They're pulling particles out of thin air. Anyway.
Roohif returns.
A limit to how many Aussies can be in this room at the same time.
Very good. Kick out Tim Bowling.
Yeah. No, you're first, Roohif.
Trying to get a hold of Miguel.
Souza?
Yeah. Like he gave me a little task. which I like. I like the long distance observation tasks.
Yeah, he's probably sleeping right now because he's over in Portugal. I mean, that's pretty.
He'd be awake by now.
He's awake, man. He was in here a few hours ago.
Oh, fuck.
He was stayed up all night, man. He's probably sleeping right now.
All right, I'll tag him in the chat.
5 Aussies in here.
Oh, Big Pon's here. Timbo, T-Dub. I assume Big Roo is an Aussie.
Yeah. Wait, is he? Yeah, I think so. Or British.
1, 2, 3.
We're racist against racist against Aussies here.
Yeah. Anyway, I'll do my Miguel reply, then I'll get out of here. Get my dinner.
Your dinner. And you're like what, 13 hours ahead of me? What time is it there? Like
6:30 p.m.
That's what I thought. Yes, 6:30 p.m.
Yeah.
29 a.m. And you're probably wondering why my ass is up at 3:29 a.m. in Arkansas, right?
You should go to bed.
No, because you know why? I got a new job. I'm on the weekend shift. So Monday is my new Saturday. I don't even have to be to work till Thursday. So you guys might have to put up with a bunch of my bullshit for the next few days. On the weekends, you still might have to put up with my bullshit, but it'll be after I get off of work at 30 p.m., which would be your 6:30 a.m. So better get your coffee. I'm just playing.
I've been sneaking out after. Oh, hang on. There's a child in the room. I've been sneaking out after the children are in bed, going to the pub and having like a steak and a cocktail. You didn't
Do you go to the pub? Do you go to the pub? Do you go to the pub and talk to flat earthers on your phone in the pub? And people are like, "What the fuck are you talking? Who are you talking to, Roohif?"
What Aussie goes to the pub and has a cocktail?
Me.
That's weird, man. What is it? A pina colada?
Usually Capra Oscar or
This
margarita.
fucking guy. God dang it. Shit.
Actually, there's a cocktail.
Give me a shout.
Yeah, needs a translator.
Lake Titicaca. What do you reckon of Lake Titicaca, Chuck? Is that funny? No. Doesn't think it's funny. I think it's funny.
Lake, isn't it?
Hey, Roohif, has anyone ever told you that you're special?
Yes. My wife all the time.
She just like loves you because you're special. You're special. Special guy. She's like, Roohif.
Oh, she doesn't like Roohif. Doesn't like Roohif. She thinks Roohif's arrogant.
You know what? She's gonna. Dude, you need to get her on here because we don't like Roohif either.
she is not a fan of the internet
that
activities.
persona. Yeah, I know what you mean.
Not a fan at all.
No, it's just so yeah. Okay, so I imagine you're a special guy. Because I don't have to imagine it because all of the rigmarole, you know what that word means? I don't know if that's a southern
Sure.
term in America, but you know what that means? All that shit you went through earlier that meant nothing
Yes,
to
I know what it
anyone,
means.
you made that shit up off the top of your head for no reason other than to just waste everyone's time. We listened to you. I was following in the chat on YouTube and shit, and they were like, "What the fuck is he talking about? Makes no sense at all to anyone." So, how do you come up with this shit? I mean, are you like some like genius comedian, or I mean, where do you come up with this nonsense?
Talking about the refraction stuff.
All of it.
Yeah, it's all empirical and all backed up. All of it.
It's not though. That's
Nuh-uh.
why nobody. No, I'm not saying not. I'm saying nuh because nobody, even people on your side, were like, "What the fuck is he talking about?"
I'll happily talk to those guys then.
All right, well then, fucking- so you do talk to other people, and they're like, "Yes, Roohif, you make total sense," and
Yeah, some people make
yeah, go.
mistakes, and I correct them. Yeah.
Well, they make mistakes, and you're the master of the universe when it comes to refraction, right?
Oh, like when was it Timbo or T-Dub? You guys confused. Someone said we're looking horizontally, and I think it was probably 2 years ago. FTFE said something about if you're looking perfectly horizontally, then it won't refract because you're staying in the same density layer. He had the idea that it's only the curvature of the atmosphere that causes refraction, and I spoke to him about that. Yeah, now he understands.
The field experts say.
Wait. What do you mean by curvature of the atmosphere?
That's what the
Some
field
people-
experts say.
Give me the fucking definition of curvature of the atmosphere.
Right. So if we're on a globe, then the atmosphere, the layers of the atmosphere also form a curve, right? So he thought that refraction was caused by a straight ray of light sort of gaining in elevation as the Earth dropped away and hitting different density layers of atmosphere. That's just not how it works. The actual curvature of the atmosphere doesn't make much difference.
Well, according to Andrew Thomas Young, it does.
Yeah,
I'll happily talk to Andrew Thomas Young as well. I think he'd agree with me.
Helio, did I told you like 15 minutes ago that there are people outside, you know, and knowledge
There are
is more
people
bigger.
outside.
There are people outside with the knowledge, you know, and it's wasted here on this server.
I'm
It's so
racist
wasted.
against people. I'm a racist against bullshit.
Because there are people saying like this, that is not working like that. And for example, that guy who said that is not working like that, you cannot read about him nothing in a sense of the science or something. But that guy is saying, you know, that's what I said, that is not working like that. I know how it's working. And I'm so sad because that people are here still and they don't realize that they need to help the humanity with their knowledge because they know better than this modern, you know, mainstream science. And they are here still talking to me that mainstream science is wrong. They need to go somewhere on some conference of the science and to write some books and to do some experiments and to prove that what they have because we are on old, you know, old science. We have these people like Roohif and he's here. Yeah, I'm talking about you,
Sasha.
Roohif.
The experts don't know what they're talking about. These guys
Yeah,
need to get.
All right, yeah. Isn't it funny how
Andrew Thomas Young's an expert.
tries to
Then why
act
you're
like he
here?
agrees with
I'm
us,
so
but then he
sad.
just says some bullshit that's just totally opposite to what we're talking about?
Andrew Thomas Young is an expert. I think we would agree that the curvature of the atmosphere doesn't make a huge difference.
He disagrees. He says it's a prerequisite for the type of refraction.
Can you point it out in one publication that he said that's what you said now?
Yeah, that's what he does. He's just like, oh,
No,
this
no,
says
no. He
this,
said
and
that
I
he will
agree, but it's
agree.
not.
He said that he will agree with him. Can you now take me out the sentence, the same what you said that guy, that scientist saying whatever he is.
No, I'm not. I'm not claiming he doesn't say it. Right? Timbo's making a claim that Andrew Thomas Young thinks the curvature of the atmosphere makes a big impact. I'm saying I don't think it does,
Wait,
and I
do
think
you
Andrew
think?
Thomas Young would
Hold
agree.
on. Do you think
Curvature
there
of the
is? Hold
atmosphere.
on.
What's
Do
that?
you think there's such a thing as curvature of the
Yeah,
atmosphere?
yeah.
Yeah, there's density. We're on a
Yeah.
globe, so the density of the atmosphere will also form.
What globe? What globe? Where?
Come on, Elio.
Yeah, nigga. I've been asking you ask the whole fucking time.
Veni să preluați schimbul.
Yeah, it might sound like I'm getting excited, but I asked this motherfucker this 2 hours ago.
Why should density of atmosphere to make sphere?
But let's say it this way: if the Earth is a globe, then the
Yeah.
atmosphere will be curved. Do we agree with that?
Why? Why?
No.
Why?
You don't agree with
Why?
it?
That's the dumbest shit that anybody could ever say. Come on, man.
It's a conditional. If the Earth is a globe, then the atmosphere will have a curved density, right? Do you agree with that?
Why?
Density? What the fuck is that?
Why?
That a straight ray of light starting horizontal will sort of gain elevation as the Earth drops away, and therefore go into
I
different
think that
density
these
atmosphere.
people always forget that Earth is moving 66,000 miles per hour. I don't know.
Right.
Right?
Oh,
How does a gradient?
66,000 miles, not per year, per hour.
Curved density.
Yeah, if the
Yeah.
Earth is a globe, we agree that would happen.
What I'm
Right?
saying,
Look
Roohif,
that
you
up.
need to
Give
write
me
a
a
book, man.
definition of curved density, Roohif. Give
That
me a
I'm saying,
definition
Roohif,
of that shit.
you need to write a book. You have some new knowledge, and even that guy, Thomas Young, he has not. You need to, upgrade him.
No, I think Andrew Thomas Young is an expert on refraction.
Then why you don't leave? Why you don't leave?
I want to say
But
calmly.
who are you? I don't understand. I heard so many things that you claimed that I never heard that any scientist claimed. That mean that you have your citation, and I'm still asking why you don't have your book. Why you are here? Why you are not?
Mr.
I'll
Sasha.
say it calm. I'll say it calm. Hey, Roohif.
Hello, everyone.
Can you go ahead and give us a definition of curved density? Can you go
Our
ahead and give us
atmosphere, right? In
No,
the same way that
How about you give us a citation? I'll speak calmly instead of yelling at your
It's
dumb
easy.
ass. Give us a
both.
definition of curved density.
our
Definition,
atmosphere would.
citation, throw it out there. I mean, instead of just throwing out whatever weird shit you're saying, why don't you show us where you got it from? I just don't know what I don't know what curved density is. Why don't you
Helio,
help
now
me with
he will
this?
explain what he meant with that. That doesn't exist, that citation, but he will explain it. Is it that?
Right.
True?
Yep.
Oh,
Oh, explanations are
I knew
were-
that's the thing. It's you know what is Schneehafensen of multiplication of the Klingen? You know what's that?
I have no
But
idea.
I
what you're
want to
saying.
I want to hear it in your language, Sasha. Just tell him how full of shit he is in your language.
Multiplication of the light dust. Did you ever hear for that?
Okay. Anyway, if
Did
we
you
are
hear?
on a globe,
No, Roohif,
then
did
the
you hear for
atmosphere curves as well.
multiplication of the light dust? Did you hear for that?
Multiplication of
connected with
light
it.
dust.
Yeah, did you hear for that?
I have no idea what that means. No.
There is no citation for that. That word doesn't exist. But now I will explain what that means. That means that everything it works and that Earth is sphere. If you have that kind of multiplication of light dust, that proves that Earth is a globe.
What?
What? You never heard for multiplication of light dust? You never heard that?
Get's been trying to get in.
Man, you need to educate yourself.
Jet's here.
Learn what is light dust, what is the speed of light dust. Learn what is the light dust, speed of the light dust, angulation of the light dust, and you will understand how it's easier to globe like that.
Anyway,
Yeah.
if we are on a globe,
Why we need to listen your citation and your stories anyway? Why is mine not good?
If you've asked me a question and you want me to answer it,
I ask you a question about Stardust, but you are not giving me anything.
Stardust? Yeah, I have no idea. I don't know.
You have an idea. Okay, great. Why you don't have
Hey,
idea?
hold on, everybody.
About
Hold on,
curving
everybody.
density, and then you don't know nothing about light dust.
Well, we have a new person.
Because you cannot
not new.
have you cannot have the curvature of atmosphere or density without light dust. Did you know that?
I don't understand.
Stardust.
Okay. Anyway.
No, anyway, you cannot move from here. You said a curvature of the atmosphere, and I said the light dust. And I ask you now, how you can have the curvature of atmosphere without light dust? Tell me.
I don't know what light dust is.
Then educate yourself.
I don't know
educate yourself. You cannot come here and speak about pseudoscience if you don't know more pseudoscience.
Okay.
We don't know what freaking curvature or density is there, or whatever the fuck you said earlier. We don't know what the fuck that is.
Would you like me to answer it, or you just want
Be
to?
real, man.
Do you want me to answer it?
Yeah, answer.
Okay. If we are living on a globe, right, then our atmosphere.
Wait. No, you're gonna have to give up. No. Before you say if,
but if you are living on a cube, what then? If you are living on a cube, what then?
Hold on, Sasha.
Sorry.
Every time you come in here and say, if we were living on a globe, that means that you don't know whether or not we're living on a globe.
Exactly.
So let's talk about what we all can experience together. The level stationary plane that we all observe.
Just light we experience.
We don't have to pretend to live on a globe, dumbass.
Anything.
The globe. The flat
globe.
earth.
Okay. Why are you a flat earther? I assume you are, but why are you a flat earther?
Well, because I personally found how the company Airbus indirectly prove that we live on a flat earth.
Oh.
Yeah. And not just because of that. This finding is actually quite new for me, like 2 or 3 years ago. But I'm a flat earther long time before. So, yeah.
How did Airbus expand on the Airbus thing?
Yeah, sure. At the Airbus factory in France, they built a huge building, factory, and inside this building, the floor is super flat, because it's made to be the printing area for this machine. And this machine is like a 3D printer. It's a CNC machine, and it's moving on a printing area surface of 200 meters long, and I'm not sure, a couple of meters wide, like 5 or 8 meters wide. Yeah. And this printer is laying carbon fiber, nanometer carbon fibers, in all sorts of patterns, yeah, but is laying them with nanometric precision. So they achieve the best structural resistance because these large carbon fiber structures which they are printing, they are the structural resistance of the airplanes, the skeleton of the Airbus A380, one of the biggest airplanes in the world. Yeah. And to calibrate this machine, because the printing head has a height of 5 meters or so, and when it's moving along the track, um, it's a U shape, you know. And when it's moving along the track, you can have the bottom like being misaligned with the top of the printing machine. So they had to install two linear encoders. So they worked with the linear with the encoder manufacturer Renishaw from USA. It's one of the best in the industry. Uh, and they built these giant linear encoders, like a 200-meter long band strip across which you have a laser head reader diode moving across this ruler, and it's taking readings for each nanometer that it's traveling, you know. Those band strips are laser engraved, so they are very, very precise rulers. Uh, Now, they found that, so to calibrate it, they used two plumb bobs at the both ends of this machine. And that plumb bob was not just ordinary rope, it was a high precision cobalt wire. So its diameter doesn't change over its length, you know. And because of this wire, yeah, when they hang it from the ceiling to the bottom, they found out that these two plumb bob wires, they are perfectly parallel with nanometer precision on a distance of 200 meters apart from each other.
Do you have a
And
link
this,
to all this?
sorry?
Is there a link to all this? Because I got to go in a sec.
A
I've
length
googled
of,
some stuff. A link that I can read.
oh, a link?
Yeah.
Well, this was described on Renishaw webpage.
Renshaw?
Yeah,
Renshaw Airbus.
Renishaw.
How do you spell
No,
it?
you just search Renishaw. It's a encoders manufacturer, linear and rotary encoders.
Oh, Renishaw. Okay.
Yeah.
Cool. All right. Would it be on the Renishaw website? This story?
Um, it was, but their page changed. Like I can't find anymore. It was probably in About Us or somewhere. Um, they were they were making an advertising to themselves, like how they collaborated with the company Airbus, how they built these linear encoders, you know, and they worked together to build this CNC machine.
I think I found
So
it.
yeah.
think I found it. Cool.
Okay.
I'll have a read. I gotta go and make
Yeah.
my wife some Timbo and T-Dub. I have to make my wife some fairy bread. I'm not joking. All right.
And of course, you can contact them. I'm pretty sure they will give you more details.
What is your profession? See, old friend, I brought more soldiers than you did.